The energy tower's concept is based on a very well-known physical principle in which hot air rises and cold air falls. To demonstrate this principle, we use a small tube and put dry ice at its top. In this model, the dry ice cools the air. The cold air descends and rotates a small propeller at the bottom of this tube. In the energy towers, seawater cools the hot, dry air, and the cold air falls and rotates turbines. The energy towers will be located in a hot, dry area near a large water source, such as an ocean or a sea. The seawater is delivered by pipes or canal to the operational reservoir, and then pumped to the top of the tower. There, the water is sprayed in small droplets by a spraying system into the hot, dry air, evaporating and cooling the air. As the air cools, it falls and gains high velocity. The wind speed can reach 50 miles or 80 kilometers per hour, rotating turbines located at the bottom of the tower and producing electricity. The brine residue is collected and stored in the brine reservoir, and from there it is conveyed by pipe back to the sea. 45% of the energy produced in this process is deliverable as electrical power. 33% is used for water pumping to the top of the tower, and the remaining 22% are energy losses. Such an energy tower can provide a city of around 1 million residents with all its electricity needs, which is equivalent to 460 megawatts average annual production. To achieve this energy production, the energy tower dimensions must be approximately 1,200 meters in height and 400 meters in diameter. The reason for building the energy tower plant so high is that the production of net deliverable power increases significantly as the tower height increases. The principle behind the energy towers is to exploit a well-known global meteorological phenomenon called the Hadley cell circulation. The Hadley cell circulation is a natural huge heat machine that transfers energy from the equator to the desert areas of the world. The circulation begins when hot, humid air rises from the equator. As it ascends, it becomes cool and dry by shedding rain. This dry air later travels north and south and descends towards two belts. As it descends towards the ground, it is compressed and becomes very hot and dry. This is how the Earth's large deserts and arid regions are created. This air flows back towards the equator, and the process repeats itself. The energy tower's operation is based on harvesting this hot, dry air as it descends above the desert regions. It flows day and night, and thus allows the energy towers to operate continuously, unlike all other solar energy facilities that produce energy only during sunshine hours. In comparison to tall building structures existing today around the world, such as the Sears Tower in Chicago and the Twin Towers in New York, the energy tower's height will be more than twice the height of these structures. The energy tower's project in its entirety is based on well-known, proven existing technologies. In comparison to other non-polluting energy sources such as solar, geothermal, wind, and hydroelectric power, the energy tower is only slightly more expensive than hydroelectric power and far less costly than wind, geothermal, and solar power. One must remember that the energy tower's global potential far exceeds the combined output projections for all the other forms of non-polluting energy production. In comparison to other polluting energy sources such as nuclear, coal, oil, and gas, the energy produced by the energy towers is not only renewable and clean, but also cheap. As the height of the tower increases, the electricity cost decreases significantly, and this is the reason for a tall structure. The Israeli Electric Corporation examined the possibility of incorporating one energy tower with an average output of 460 megawatts in their long-term planning computer model for future power plant construction. They found that by incorporating one energy tower in an optimal coal-based plan, the expected cost saving would be $1.1 billion. By incorporating one energy tower in an optimal gas-based plan, the expected cost saving would be $800 million. There are over 40 countries in the world with desert regions that can benefit from the Hadley cell circulation. These countries can build energy towers and receive clean, non-polluting, inexpensive power. Most of them will be able to export electricity to neighboring regions. potential that exists for the energy towers is to supply approximately 20 times the current world consumption of electricity. In practical terms, in the majority of arid countries, approximately 50% of the electricity can be provided in the near future by the energy towers. The energy towers are a revolutionary idea in that they can produce large amounts of power with no pollution. Potential side effects have all been carefully studied, and technical and engineering solutions have been developed to ensure that the surrounding environment is protected. The main environmental concern was the potential for salt spray drift. Utilizing proprietary technology, almost all the brine residue from the water spray will be collected in the tower and in the diffusers. The balance of the salt spray drift will be contained and collected in an area surrounding the power plant, especially designed and engineered for that purpose. The collected water is stored in the brine reservoir, and from there it is conveyed by pipe to a controlled disposal system back to the sea. That is how the problem is solved and the environment protected.